Hello, this is P. Mohammed, and this is my tableau, and this my other tableau. We three friends are going to solve an interesting problem for you in this video. Imagine you have a rope suspended from two ends, and we want to find a relation for the equation of this curve. You will see that the equation of the curve is actually a hyperbolic cosine with two parameters. Now let's go and solve it.
Okay guys, let's get started. At first, we need a diagram, which I draw it here. This is x and axis and y axis. I put the center of the coordinate system in the lowest point of the rope. This rope is suspended from both ends. In each point, there is a tension which is tangent to the rope, and this tension is not constant in this point and this point, and it varies from one point to another one, and this is T referring to tension. But don't be worried about this non-constant T, because as you will see, we won't need it actually. This is X and Y. This is a point of the rope. We can actually use the second law of Newton from this part of the rope. This part of the rope has zero acceleration, so actually the forces in each direction should be equal. In x direction, the forces, we can consider a t0 here. T0 refers to depends on linear density of the rope, and actually is one of the parameters. T cosine of theta. This is theta angel, as you guess. T cosine of theta is equal to T0, right? And in y-axis, we have T sine of theta is equal to, this part of the rope has a weight, and actually T sine of theta is holding this part against gravity. So this is rho, actually the mass of this part, in G. The mass of this part, I put G first. This rho is linear density of the rope, and the length of this part is by an integral. Integral of radical 1 plus y prime squared dx from 0 to x. If you haven't seen this before, this is simple. This is the Euclidean relation. If you consider a small element of the rope, this is dy and this is dx, so dl will be equal to dx squared plus dy squared, which is equal to, you can actually take dx out of the radical, and it is equal to dx in radical 1 plus y prime squared dy divided by dx, which is y prime. Okay, let's continue. You can divide both sides, so we have tangent of theta equal to rho g divided by t0 integral radical 1 plus y prime 2 dx from 0 to x. And what is tangent of theta? Tangent of theta, this is theta angle, and tangent of this angle is derivative of y with respect to x in this point. So this is our differential equation. We're gonna solve it. Now we can derivative from both sides, so our differential equation will be y double prime equals rho g divided by t0 in radical 1 plus y prime squared. And here, maybe you know that we name y prime equal to another actually quantity, for example u, and so we will have y double prime equal to u prime, and if we replace these we will have rho u prime equal to rho g divided by t0. Here we, yes, right, and radical 1 plus u squared, and we can write it like this: du on radical 1 plus u squared is equal to rho g divided by t0 dx. And now we can integral from both sides. So integral of du divided by radical 1 plus u squared is equal to rho g divided by t0 x plus some constants that I don't write it now because we have another integral yet. And the LHS, the left-hand side, you can do it by actually parameter changing. You can take u equal to tangent of a virtual angel of like alpha, and so you have du equal to secant squared of alpha, and if you replace this, you will have rho g divided by t0 x equal to integral of du is secant squared, it have the alpha 2, the alpha, and the denominator is radical 1 plus tangent squared, which is radical secant squared, which is secant to the power of 1, and the seconds cancel each other, and this is integral of secant, which is integral of cosine alpha d alpha, which is actually integral of secant, maybe you know it by heart, that is ln of secant alpha plus tangent alpha. And you should know that what is the alpha, we named tangent of alpha by u. So if this is the virtual angel alpha, tangent is u divided by 1, which is u, and is tangent of this angel, and this is 1 plus u squared. And so this will be ln secant. We can see from the triangular that secant, which is 1 divided by cosine, is radical 1 plus u squared, and the other sentence in ln is tangent of alpha, which is u. And actually we should try not to be lost. This was equal to rho g divided by t0 x, and what was u? U actually was y prime. So we have this ln of radical 1 plus y prime squared plus y prime equals rho g divided by t0 x plus the constant c. Now, when x is 0, y prime is 0. And let's put this point, actually x and y prime. So ln of y1, which is 0, is c, so we don't have actually a constant. So till here, our differential equation has been updated to this: ln of y prime plus radical 1 plus y prime squared is rho g divided by t0 x. So we have 1 prime y prime plus 1 plus y prime squared equal to exponential of rho g divided by t0 x. Okay, and so I want to actually have y prime pure prime squared is equal to e to the power of 2 rho g t0 x, okay, plus y prime squared minus 2y prime e to the power of 2 rho gx divided by t0, and these y prime squared fortunately cancel each other, and we will have it is getting simpler. 1 is equal to e to the power of 2 rho g divided by t0 x minus 2y prime e to the power of 2 rho g divided by t0 x, and we are reaching the final answer. And now we want y prime pure, and now e to the power of 2 rho g t0 x minus 1 divided by 2 e to the power of 2 rho g divided by t0 x will be y prime, which is dy divided by dx. Maybe you understood that we made a mistake here. Here we didn't have a 2, okay? A little mistake. It's good for us. And so we can multiply the LHS by this fraction, e to the power of minus rho g divided by t0 x, e to the power of minus rho g divided by t0 x. If we multiply the LHS by this, we will have e to the power of rho g divided by t0 x minus e to the power of minus rho g divided by t0 x divided by 2 is y prime. And this is sine hyperbolic of this thing, rho g divided by t0 x, and this is dy divided by dx. And we're going to finish another simple integral. So y is integral of sine hyperbolic is cosine hyperbolic of rho g divided by t0 x. This is the answer, of course, plus some constants, but it's not important. Actually, it's another parameter. If you're concerned about it, in the lowest point, if you see the diagram, in the lowest point of the rope, we have x and y equal to 0. So if x is equal to 0, y should be 0 too, and we can actually find that constant. So here we have plus some constants. And this was the problem. Actually, the rope which we suspend from two ends has this shape. This is the equation. Okay, and maybe you say that the rope may be like this, or like this, or like this. This is related to the parameters in the relation rho and t0, and it's not important. If you like this video, I will be happy if you like my video and subscribe my channel, so you can use next videos on my channel. I am P. Mohammed. I hope you enjoy solving problems.